Okay, and section 10.6 is going to be a review of trigonometry, what we learned in geometry and algebra 2. So to start with, we'll talk about the trigonometric ratios. We generally start with sine, cosine, and tangent. To deal with that, though, we need a little vocabulary to remind ourselves. If we name a triangle, we usually call the angles capital letters, capital A, B, and C. Generally, C is the right angle, because we're going to be talking about right triangles in this particular section. And the sides across from them, the side opposite A is going to be little a, the side opposite B is going to be little b, and the side opposite C is going to be little c. And all in relationship to A, we generally say that the one that's across from it is the opposite side. Okay, the hypotenuse is the one that's across from the right angle always, and the one that's next to A, and then in other words, the one that's touching it to, we say is adjacent. So we're going to be using opposite, adjacent, and hypotenuse. So, that said, the three trigonometric ratios that we're going to study in this particular class are going to be what we call the sine of A, which we call sine with no E on it. That's the abbreviation, of course. So sine of A is always equal to the opposite side okay, over the hypotenuse. So for A, it would be A over C. That would be the sine of A. Okay, the cosine ratio is always going to be the adjacent over the hypotenuse. So in this case, it would be B over C. And the tangent of A is always going to be the opposite over the adjacent, which is A over B. Okay? So with these ratios that we can write, these true equations that we can write with any right triangle, we can set up these sentences and we can use them to solve real world problems, which we'll see in a minute. So just to illustrate, if we want to find the sine and cosine and tangent of angle A in this problem, okay, the first part here we need to recognize is that we do not have the hypotenuse. Okay, so to figure out the sine and the cosine, we're going to need that hypotenuse. So we know the Pythagorean theorem at this point, so we can go 5 squared plus 12 squared equals c squared and solve that. Turns out that the answer is 13. So now that we have all three sides, we can go ahead and write the ratios. Okay? So the sine in this particular case is going to be the opposite of A, which is 5, over the hypotenuse, which is 13, so 5/13. Keep in mind when we write these fractions with numbers, if these were reducible, we should reduce them for sure. Okay. Cosine of A is going to be the adjacent side over the hypotenuse, so 12 over 13. And then finally the tangent is going to be the opposite over the adjacent, which is 5 over 12. Okay. So one of the things that we learned in geometry and in advanced algebra is that to remember these, we usually wrote the word SOHCAHTOA. So the SOHCAHTOA information, and it tells you which sides go with which trig function. So sine ratio involves the opposite over the hypotenuse. Cosine involves the adjacent over the hypotenuse. Tangent involves the opposite over the adjacent. So that might help you remember which ones go with which. Okay, so let's see, how do we use the trig ratios to solve the problem? So in this particular case, we know that this angle A is 40 degrees. We know that this side B over here is 150. And what we want to find is side A. So as long as we have two pieces of information in a right triangle, we should be able to find any piece of missing information that we're after. So what you want to ask yourself is that if I use this angle right here, okay, the side that I need is the opposite. The side that I have is the adjacent. So that's going to tell you which trig equation to write an equation with. And in our case, opposite and adjacent is going to involve tangent. So hence we're going to write the tangent of 40 equals A over 150. So remember the tangent or the sine or the cosine, whichever one we choose, it's of the angle. So we're going to take the tangent of the angle, 40, and that equals the opposite over the adjacent. Notice that we only have one variable in there. And to solve that sentence, we just need to go times 150 on both sides, and we'll have our A by itself. So when we do that, they end up with 126 centimeters approximately. For our purposes, we round to 3 decimal places. So make sure your calculator is in the degree mode. So check your mode, make sure it's in degrees. And then if I go 150 that is, times tangent of 40. Notice the tangent button is right here, so our sine and cosine right next to it. And if we do the math, we get 125.865 centimeters. So for our purposes, of course, we would give it as a more exact answer than 126, and that would do it. All right, let's take a look at a couple more. Before we look at the last few problems here, we have just to make sure we're clear, the angle of elevation and angle of depression. Okay. If we are the observer here, the angle of elevation is always going to be the angle with the horizontal, okay, going up into the air, if you will. The angle of depression is going to be with the horizontal going down to something below. Okay. So keep that in mind. And when we tackle this next problem, we are at this point right here, looking up at this tower. Is going to, this angle right here, the 57.2, would be our angle of elevation because it's with the horizontal on the bottom and it's going up. We know this distance that can be measured as 125 feet, and we want to know how tall is this tower. So if you look at the angle that we're given, we need the opposite. We have the adjacent. So opposite and adjacent. So katoa would be tangent. So we set up another tangent sentence just like we did in the last problem. Okay, and then from there we would multiply both sides by 125. And so for us, a more exact answer would be 125 tangent 57.2. So we would write the answer as 193.962 feet. Make sure you have units on it. And that would be the height of the tower. Another one. This one says we got a building that casts a shadow that's 25 meters long. The building is 21 meters high. Okay, and we want to find what is the angle of elevation. So this time we don't know the angle, but again, looking at the angle that we're given, we know the opposite, we know the adjacent, so it's another tangent sentence. So when we set it up, we can write tangent A equals 21 over 25. Now, when we solve that sentence, okay, we're looking for the angle this time, and we need to get that A by itself, so it means we need to get rid of tangent. So we do that by by taking the tangent inverse of both sides. Okay? So that's how we get an angle, is we take the tangent inverse of both sides, because the tangent inverse and the tangent cancel each other out and give us A. And then on the right side, it's a calculator problem. So we'll do tangent inverse, which you'll notice is right above your tangent button. So tangent inverse, 21 divided by 25. And we get our answer of 40.030 degrees. And that would be the angle of elevation in this case. Okay. All right, now we just saw a couple of real problems here. I want to go back to the previous problem. Just as an aside, if we were to, let's just say for argument's sake that, that we wanted to know the distance from the point to the top, and we want to know the hypotenuse, if you will, then in this case, instead of using the tangent, we would have known the adjacent, needed the hypotenuse, so we could have set up a cosine sentence this time, and we would have said cosine of 57.2 degrees equals the adjacent over the hypotenuse. And I want to illustrate one solving process here that we haven't covered yet. We can write the sentence, but this time the c is on the bottom, the variable's on the bottom this time. So this time we're going to multiply both sides by c, okay? And we're going to have c cosine 57.2 degrees equals 125. If we do that, c's will cancel on this side. And then the final step to get c by itself is to divide by cosine of 57.2. So instead of multiplying this time, it ends up being a division problem. And we're still using our same solving techniques to get the c by itself. But this time when we do 125 divided by cosine of 57.2, we get our hypotenuse, which is 230.752 feet, of course. Which should make sense because the hypotenuse should be the longest side. Notice it's longer than 125, it's longer than 193.6. Okay, so it does make common sense.